Hello students, this is Professor Urvish Mewada, HOD Electrical Department in Sri Swaminarayan Institute of Technology, Part Gandhinagar. I am the subject matter of the subject Industrial Instrumentation, which is in 7th Sem Electrical, and the subject code is 2170913 in the GTU. In previous lecture, we studied about the basic instrumentation system. Now, in this lecture, we will study the topic number 2 is static and dynamic characteristics of the transducer. Now, first of all, what do you mean by static and what do you mean by dynamic? Static means whenever the input is remains steady or not very, or we can say very quite slowly, then it is called static. And dynamic means input of the system, or we can say measurement system, is continuously changing. It means it is called dynamic. So we'll start with the static and dynamic characteristic one by one. We will check in detail all the characteristics. So the static characteristic, as I explained you, as it remains constant, means input of the system will remain constant or vary quite slowly. Now we'll start with the first static characteristic is accuracy. Now accuracy means what? Accuracy is a difference between, we can say, expected value or measured value. So it is a difference between expected value, means our expected value is suppose 1 and the measured value is suppose 0.9, then the difference of that two is called the accuracy. Accuracy is defined as the closeness of the transducer output, or we can say inaccuracy of the measurement from the true value by calculating the absolute percentage error. So the error can be calculated from the values which we get after measurement. So yn, here yn indicates the expected value and xn indicates the measured value. So the unit of accuracies are here. Two more expressions are given for the accuracy. One is percentage of true value. So it is a ratio of measured value minus true value divided by true value into 100. And the second is percentage of full scale deflection. So it is measured value minus true value into 100 divided by maximum scale of the instrument. Now from this we can define the percentage error also. Percentage error can be calculated when we measure the value, or we can say expected value from the instrument. So yn minus xn upon yn into 100. So all these characteristics you already studied in measurement, but here we are just recalling all the definitions of the characteristic. Now this accuracy can be more elaborated over here. Two diagram is two figures is given. Figures are given. One is in the bullseye, arrow is in the bullseye, and in this you can see in this diagram when this the dot indicates high accuracy, means it is in the center of the circle, and low accuracy means it is somewhere out of the circle. So point accuracy or accuracy as percentage of scale span and accuracy as percentage of true value, it is defined as, so point accuracy is the specified at only one particular point scale, so it is called point accuracy. And accuracy as percentage of scale means when an instrument has uniform scale and its accuracy may be expressed in terms of scale range, means whenever we measure any quantity and if that quantity express or we can just show the result in terms of the scale range, then it is called the accuracy as percentage of the scale span. And accuracy as percentage of true value means it is to specify in terms of the true value of the quantity being measured, means the quantity we are actually trying to measure, and what is whatever the value of that quantity, the instrument will measure the same quantity. So that is called the accuracy or percentage of true value. Now the next definition of the static characteristic is precision or repeatability. Now first of all, what do you mean by precision? So The precision is explained by this diagram. You can see in the bullseye all the darts are at the bullseye. So high precision means you can see over here all the darts are together, not in the bullseye but together, means very closely. And here low precision means this the mark of the darts is far compared to this diagram. So precision is basically, it is defined as the ability of the instrument to reproduce a certain set of readings within a given accuracy. Means this is called the accuracy and this is called the low accuracy. Now repeatability means repeatability is defined as the repeated output of the instrument. So repeated output means what? It is the ability of the instrument to reproduce a group of measurement of same measured quantity. And the precision of the instrument depends on the factors that cause random error. Now precision depends upon basically the values which we measure, the values which we expected and the value which we measured. So if both the values are near to each other, and or we can say very near to each other, then that instrument is called precise. Now accuracy versus precision, here the difference of accuracy and precision is mentioned over here. So in this two diagram you can see that first is high precision with poor accuracy. Now precision means what? The values which you are expecting, it is near to each other. So here you can say this is the target plate. In this target plate, see this is the bullseye, and bullseye from the bullseye you can see these are the marks of dart. Now this is high precision with poor accuracy. Accuracy is not very proper. Accuracy was also proper in this, then this all darts are in the bullseye. Now good or we can say average accuracy with poor precision. Now precision is poor, so this in this marking of the darts are very near to each other, but in this they are far to each other, but not into the bullseye. Now high accuracy with high precision. So see, you can see over here all the nine marks of the dart are in the bullseye, and all the marking are also at the near to each other. So that is why it is called high accuracy with high precision. Now poor accuracy with poor precision. So maybe some values we get from the instrument is near to the expected value, but many times we'll get the different value and that value is not similar to each other. That's why it is called poor accuracy with poor precision. Now precision is described over here. It is the we can say measure of reproducibility, means given a fixed value of quantity, and precision is measure of the degree of agreement within a group of measurement. So the precision is composed of two characteristics basically. So here all the modes of precision and accuracy means difference from the diagram we can easily understood. Now resolution or discrimination. Now you can differentiate these three figures. In this figure you can see that low density, medium density and high density. Means you can see these are the squares which are in this rectangle. Means in this you can see all the squares are together, but you can see easily, but in this case it is somewhat difficult to see, but in this case you cannot easily see the squares. So this is what the resolution is. So it is defined as the smallest increment in the measured value that can be detected. Means for a minimum input your instrument or your system will respond. So that is the resolution or discrimination of your instrument. Now resolution can be measured with the help of delta I, means all the readings you calculate divide by full scale into 100. And resolution also defined as the we can say largest change in the input that can occur without any corresponding change in output. Means whenever the input comes, according to that input your system responds, then it is called the resolution of the system. So resolution is normally expressed as the percentage of input full scale. So From this equation we can calculate the resolution of the instrument which we use for the instrumentation system. Now the next definition is linearity. As we all aware with the word linearity means what? It is a ratio between input and output. So this is the diagram which shows the definition of linearity. So in this you can see that output and this is the graph is output versus input, and this is the response of the instrument. This red line indicates or effect. So it is the relationship between change in output corresponding to the change in the input when they are in direct proportion. Now if both are in direct proportional, it means it is called linear. Now most instruments are specified to function over a particular range, and the instrument can be said to be linear when incremental change in the input and output are constant over the specific range. Now if a instrument having a range, means suppose 0 to 10 ampere, so as you are giving current in the input of the device, suppose 1 ampere, and according to 1 ampere suppose the scale of the instrument will indicates 1 ampere, then it is called linear response. Now sensitivity means sensitivity and resolution both are maybe we can say both may be same. Resolution and sensitivity means for a smallest change in the measured variable to which the instrument responds. Means if we give a minimum output in this minimum input in the system, and so according to that input your system respond, so that will be the sensitivity of the instrument. And sensitivity is the ratio of infinite decimal change in output. Decimal change means you can understand 0. Suppose 0.1, 0.2, 0.3, then it will become 1. So it is infinite decimal change in output to the infinite change in the input. So it can be measured using this ratio. And dq0 to dqi means output to the input ratio of the change in input and output of the given signal. Now also it is defined as the ratio of change in output of instrument to a change in the value of the quantity to be measured. So mathematical expression described over here, and the graphical representation of this sensitivity is, you can see over here, this is the slope of the response of the instrument from input to output, and the slope over here you can see delta q0, and this is delta qi. This I indicates input and O indicates output. So when you take the ratio of these two, will get the sensitivity of the instrument. So from this graph we can easily understand, we'll get the certain readings, and after certain readings, suppose we plot the graph like this, and we take the ratio of input to the output to the input, will get the sensitivity of the instrument. Now the next characteristic of the instrument is dead zone. Now dead zone means what? A period at which your instrument will not respond. So it is called dead space or dead zone, or we can say the range of different input values over which there is no change in the output. So over here you can see that from this point to this point there is no response of the instrument. So that is why it is called dead space or dead zone. It can be it can be happen when we give sudden input to instrument, and for particular that sudden input support instrument does not respond. So that is called the dead zone of the instrument. Now the next characteristic is threshold. Now threshold is also shown expressed using this diagram. You can see that from 0 to this this point of input, your system is not responding, or there will be a minimum detectable value period to give a detectable output range or output change. So that is called the threshold. Means for a particular minimum input, system is not giving response. After certain time system will respond. So this point is called threshold point of the instrument. So from this graph you can easily understand the threshold. Now tolerance. Now tolerance is basically defined as the maximum error that is to be expected. Means uh, every instrument has somewhat tolerance, but if tolerance is more, so that instrument is not called accurate or proper sensitivity or not having proper resolution. So for the tolerance concern, it is defined as the maximum error that is to be expected in some values. Now tolerance describe the maximum deviation of the manufactured component from some specified value, and that is called the tolerance in the case of instrumentation system. Now a range or span, so every instrument has its own range and span for the response. So the range of or span of instrument defines the maximum and minimum values of quantity that the instrument designed to measure. Suppose we use one instrument for the current measurement. The range of that current measurement instrument is suppose 10 ampere. So it is called 0 is the minimum value and maximum value is 10 ampere. So that is called the range or span of that instrument. Now the next characteristic is reliability. Reliability is associated with the output input output response of the instrument, sensitivity of the instrument, or we can say resolution of the instrument, or accuracy of the instrument. If all are correct, then we can say this instrument is reliable, or we can say it can operate in each and every condition, and it repeatedly give the same output in each and every atmospheric condition. So repeatability is the probability that device will adequately perform for a period of time under specified operating condition, and some sensors are required for safety or product quality, and therefore they should be very reliable. So that instruments is to be called reliable only when it respond properly in each and every condition and each and every period of time. So the next characteristic is instrument drift. Now drift means what? It is a variation of output for a given input caused due to the change in the sensitivity of the instrument due to certain we can say interfering inputs like temperature change or component instabilities, etc. So due to that your system or instrument will not respond for a particular time, so that is called the drift. Now the drift is we can say complex phenomena for which the observed effect that are the sensitivity of the offset value vary, and it is also can alter the accuracy in instrument differently. So over here you can see that zero drift, then sensitivity drift, then zero drift plus sensitivity drift. So here you can see that the normal characteristic and this characteristic with zero drift means both are in proportion, and over here you can see both are starting from zero, but they are going somewhat far after a certain period of time. And over here zero drift means drifting is minimum, but sensitivity drift is there. So that's why over here you can see that it is starting from this point, and after that it is the span between these two readings is changed. So that is called the drifting of the drifting response of the instrument. Now hysteresis, you all aware with this graph, hysteresis loop curve. So hysteresis is basically the effect arise when the magnetic field is reversed in a magnetic material. See, generally we have different type of instruments like permanent magnet instruments or moving coil type instruments. So all the instruments will give response according to the flux produced inside the coil, or we can say the magnetic material we placed inside the machine, instrument. So the effect arise means the problem arise whenever the field is reversed. So that reversed field can oppose the motion of the pointer, or motion of the result shown by the instrument. This is just because of the hysteresis, means all the magnetic material has the tendency to store the magnetism, even if it is not supplied with the electrical input. But whenever suppose if you give supply to that instrument, so there is a residual magnetism inside that magnetic material, and due to that hysteresis problem or hysteresis loss of that instrument, it will the signal or the field will get reversed in the magnetic material, and because of that one additional flux will produce, or will oppose the main flux, and so that the instrument respond improper or inadequate. So that is called the hysteresis. So hysteresis is also defined as the magnitude of error caused in the output for a given value of input when this value is approached from opposite direction. So that is called the hysteresis of the respond of the instrument. And hysteresis can be eliminated by taking readings in both the direction, and then taking its arithmetical mean. Means we can take more than one reading, and then we can take the arithmetical sum or average of that reading. So this is how we can minimize the hysteresis error of the instrument. Now the next characteristic is backlash. Now backlash means what? If machine is designed for here you can see that this is the teeth and this is the rail structure. So this teeth structure, you can see that this is the motion means in this direction. So this span means from this point to this point is called the backlash of the instrument, and that when this will reverse, at that time you can see that it is touching over here, and this is the same span which is offered at the time of reversing. So this is called the backlash. It is defined as the maximum distance or angle through which any part of the mechanical system may be moved in direction without causing motion of the next part. Means suppose this belt travels from this point to this point, so it will not offer any motion to this belt. So this is called the backlash of the instrumentation system. Now creep is the mechanism of creep depends on the temperature and stress which will produce during the measurement, or due to the different atmospheric condition. So that is called the creeping. Means suppose we are talking about moving coil meter, then suppose there is moisture present in the atmosphere. Due to that moisture, coil may get in the coil it may get corrosion, and due to that it will show different reading when we measure. So that is called the creeping of that instrument. So these are the static characteristic of instrumentation, or we can say transducers. Now we'll move towards the dynamic characteristic of the transducer. As I already explained you that the dynamic characteristic measures the values, means input is continuously changing. So that is called dynamic response of the instrument. So dynamic characteristic of a measuring instrument actually refers that measured variable changes continuously or rapidly. So that is called the dynamic response of the instrument. And the characteristic of the dynamic characteristic of the transducers are: the first characteristic is speed of response. Now speed of response is associated with as we give the input, according to that input your instrument behavior means instrument behaves, or it will give the output, that is called the speed of response. Now speed of response is basically define the rapidity with which instrument or measurement system respond, and response time. So the time which is taken to respond, it should be minimum for the particular instrument, or we can say sensitivity must be proper. So that is called the response time. So the response time is basically required by the instrument or system to be settled to its final steady state position, and it is appreciable, it should be minimum as possible. So this is the speed of response. Now second is measuring lag. Now in the measuring lag, the measuring lag is basically the instrument does not react to change in input immediately, or offers the delay to show to express the measuring quantity. So that is called the measuring lag, and the delay in the response of the instrument to change in we can say measured quantity is known as the measuring lag. And this lag is usually quite small, but this lag is becomes highly important when high speed measurements are required. Means whenever we require a quick response of the instrument, at that time this lag should be minimum as possible, and from that minimum lag we can say that instrument sensitivity is very good, and that can be used for we can say research technology or space technology or aircraft technology. So measuring lag is associated with the response of a system when we give the input, and for that particular input instruments take some time to show the reading. So that is called the measuring lag. Now the next characteristic, in the measuring lag we have the two types. First is retardation type and time delay. So retardation is basically associated with the pointer to reaches up to a particular level after overshoot. So this is a type of measuring lag. Response begins immediately after a change in measured quantity has occurred. Means it offers it shows the response, and then after quickly suppose it gets steady, then that is called the retardation type of the particular instrument. And the time delay means measuring lag the response of the measurement system being after a dead zone. Means suppose your instrument is not giving a response as we give the input. So after dead zone suppose it shows the reading or show the output. So that is called the time delay of that instrument. So as I already explained, it should be minimum, or minimum backlash is also we consider, and minimum we can say dead zone. If the instruments having minimum dead zone is considered for the measurement system. So these two are the types of measuring lag. Now the next definition for the dynamic response or dynamic characteristic of the instrument is fidelity. Fidelity is basically associated with to reproduce the output in the same from the input. Means it is the ability of system to reproduce the output in the same form as the input. Means we can take continuous reading having same input quantity, and your instruments show the same output. So it is called good fidelity. And suppose if a linearly varying quantity is applied, means suppose a dynamic quantity applied in as an input in the instrument, then the system applied to the system, then if the output is also linearly varying quantity, the system is to be have 100% fidelity. Means if we give varying input in the instrument, and your system will show, or your instrument will show the same output, means varying output according to the varying input. So that instrument have the 100% fidelity. Now dynamic error. So dynamic error is basically difference between the true value and quantity changing with time, and the value indicated by the instrument is having if no static error is assumed. So uh, basically error is generated only when the input is given, and according to the input your instrument will not offers the output, means both are different. So it means it is called the dynamic error in the measurement or instrumentation system. So dynamic error of the instrument is the combination of the fidelity and time lag. So 100% fidelity should be required and minimum time lag is required, so we can minimize the dynamic error of the instrument. Now overshoot, this is associated with a pointer deflection. So this is the time taken to show the response according to the input, and this is the percentage output change. Now here we are measuring suppose 100% over here. This is the 100% line. Now you can see that as time passing your pointer is showing deflection, and after this point the signal is retarded, and then again it will go up, but the peak of both the signals are not same, means from the previous one this is somewhat minimum, and then after it will get steady after particular time. So this is called the overshoot, means it will require 2% of settling time, and for this period overshoot occur. So this is nothing but the response of instrument when we give the input, and according to that input pointer will get deflected, but it will go beyond the measured quantity, and then after it will get steady. So that is the period, that period is called overshoot period, or we can say settling time of the instrument. So overshoot is nothing but the deflection of the pointer, and pointer does not immediately comes to the rest, and it is steady state position but goes beyond. So this period is called overshoot period, and the maximum amount by which the moving system moves beyond the steady state position is called the overshoot of the instrument. So from this graph you can easily understood the overshoot and overshoot period and settling time period. So these are the static and dynamic characteristic of the instrumentation system or transducers. So this is the assignment question of this related topic. The question is explain the static and dynamic characteristic of the instrumentation system or transducer, and this question is repeatedly asked in the GTU. This is the most timely question of this chapter. All the instructions which are related to the assignment is written over here, and you can take snap of this also, and you can write down the assignment question, and you can read the instructions carefully. So thank you student. Jai Hind, Vande Mataram. Thank you very much.